Hello guys, I'm Alukosha Enoch and welcome to my tutorial class on transformation matrix. In this tutorial section, I'll be working on how to use matrices to describe transformation, and we'll be taking a look at reflection, enlargement, and rotation. Okay guys, let's take a look at the first question. Write out the matrices for the following given transformation. Okay, so the first given transformation here is rotation, so we have to describe rotation 90 degree clockwise using transformation matrix, then 180 degree to 70, and so on and so forth guys. So let me get started with that task now. So guys, the first I need to introduce you to a concept now. Okay guys, if you can recall, in matrices there's what we call identity matrix. Okay, so identity matrix is just like your identity number one. So when you use identity matrix to multiply a given number, the identity of the number will remain the same. Okay, so I'm going to work with that now. Then I will split my identity matrix into um, corresponding base vector. So we call base vector. Okay, so let me get started now. I just need to quickly make this note so that you understand what I'm trying to do. Okay, so now the first thing now is don't forget in your Cartesian plane, this is your y-axis, this is 0, and this is your x-axis. To the left hand side of x-axis you have minus x and minus y, like that, but I don't need that. Okay, so now let me go for my identity matrix. Okay, so identity matrix is giving us don't forget to x before y. You have x first, then before y in your coordinate system. Okay, so identity matrix is 1 0 0 1. So this is the identity matrix. Okay, so then I'm going to split this into corresponding base vector. So this is x is 1 0. So this point here is 1 0. So that is from the distance from here. So it's a boundary point, 1 comma 0. Okay, and this is my x value. So this is known as the base vector 1 0. This is base vector now. So and the second component of the coordinate is 0 1, and from 0 down this is 1. So just at this place 1, this is 1 2. So this is 0, because x is 0 on y axis, a boundary point 0 1. Okay, then you just mirror that, just like you have in reflection. So just mirror this to the left hand side. So that would be a negative of this now, minus 1 comma 0. And also for y, just mirror y. So that would be 0 comma minus 1. So now how do we apply this now? So now don't forget that originally we have the base vector. So what we're going to do now is can I change this color again? Okay, let me just go with blue this time around. Okay, so what we have now here is you have base vector. This is x, and x is 1 0. Then the second component is y, and that is 0 1. Okay, and this is the point. This is the starting point here, and this is the starting point here for x and for y. Okay, now so let's get started now. So I want to write, I'm going to let me just quickly draw this so that I'll complete the task here very fast, because I have a lot of questions to solve, and I'm going to apply this also to transformation question. So what I'm going to do now is I'm going to write clockwise here, c-wise, because I want to complete the task together, clockwise and anti-clockwise. Then I have AC-wise here. So I want to write transformation matrix for 90 degree clockwise, 180 degree clockwise, 270 degree clockwise here. Then 90 degree, 180, 270 for anti-clockwise here. Okay, now so don't forget that originally this is x now. Let me use another color this time around to effect my can I go with green this time around, deep green? Okay, so now from here, now this is x, because x before y, you move x, the display will be such that you start from x then to y. Now from x, starting from x, base vector starting from x, 1 0 will change to what? For 90 degree clockwise. And don't forget, this is direction of clockwise. This is clockwise and this is anti-clockwise. So clockwise now, you move from 1 0 change to what? 0 minus 1. So 1 0 change to 0 minus 1. This is 90 degree clockwise. If it were to be 180, 1 0 will change to minus 1 0. If it were to be 270, 1 0 will change to what? 0 1. Okay, so like that. So now, but I want to work with a 90 degree clockwise first. So I think let me just use arrow. So I'll do 90 degree clockwise here, 180 degree clockwise here, then 270 degree clockwise here. Then I'll do the same for the corresponding anti-clockwise here. Okay, so then I can write now 90 degree here. So for 90 degree, I start with x. Don't forget to start with x to see what x will change to before you go to y. Similarly, you do the same thing here. You start with x, then you see what will also happen to the base vector of y. So now x change to what and y change to what? Originally it is 1 0. X is 1 0. This is x 1 0. So x 90 degree clockwise, 1 0 change to what? 0 minus 1. So this is 0 minus 1. Also starting from y now, because when you start from x, this x, I'm done with x, then the next component is y, 0 1. So 0 1 change to what? 1 0. So guys, the transformation matrix 90 degree clockwise is what? 0 minus 1 1 0. Transformation matrix 90 degree rotation clockwise direction, that's the center 0 0. Okay, so I'm going to complete the same for the remaining one now, so I don't need to waste much time, and you already understand, you have a good understanding of the concept now. So I need not to write 90 degree 180 270 for anti-clockwise. I'll just go ahead with the transformation matrix and complete the task accordingly. Okay, so for 180 degree now, so 1 0 change to what? Minus 1 0. So the x, you start from x before you go to y. So this is x. 1 0 change to what? Minus 1 0. Minus 1 0. Then the next starting point is for y. So 0 1 changes to what? 0 minus 1. Okay, so this is 0 minus 1. So that's transformation matrix rotation 90 degree clockwise. Similarly for 270, 1 0 move down. This is 90, 180, 270. So to 0 1. Then from y base vector 90, 180, 270 minus 1 0. So I'm through with the first task. So let me do the same for the corresponding anti-clockwise. Okay, for anti-clockwise now, I mean that I'm going to change the direction. So 90 degree anti-clockwise, 1 0 change to what? 0 1. X. So this is the red, changes to that. Then similarly for y, anti-clockwise 90 degree, 0 1 change to what? Minus 1 0. For 180, 1 0 change to what? Minus 1 0. Then 180 for y component, 0 1 change to what? 0 minus 1. So what do you observe about 180? So irrespective of the direction, 180 is the same because either clockwise or clockwise, the transformation matrix is the same for rotation. Okay, finally 270 and the clockwise, and 1 0 changes to what? 0 minus 1. And also starting from y now, this is 90, 180, 270, 1 0. So guys, this is video. You can pause the video and get a better understanding, and I'm through with the first question. So let's go to the next question now. So an enlargement scale factor. So I want to write transformation matrix for this one too. Enlargement scale factor for the following scale factor: minus 2, 1.5, 0. So this is 1 over 4 and this is 3. This is 3 over 2, something like that. Okay, so let's take a look at it very fast because I need to apply virtually everything. Okay, don't forget we have a base vector already. You understand what base vector is all about, and you understand what identity matrix is all about. So like in rotation, for enlargement you just multiply scale factor times identity matrix, and x is 1 0 and y is what? 0 1. So that's how I'm going to complete the task now. So let me call this task A for minus 2. For minus 2 now, the scale factor is minus 2 here. So I have minus 2 minus 2 to multiply this one. Don't forget that the matrices. Let me just solve this one, then I'll go ahead and complete the remaining one, like 1 0 0 1. So this is scalar product in matrices. When you have scalar product, you just use the number to multiply out straight. So minus 1 times minus 2 times 1, that is minus 2. Minus 2 times 0, that is 0. Minus 2 times 0, that is 0. Then minus 2 times 1, that is minus 2. So the transformation matrix, enlargement, scale factor minus 2 is minus 2, 0, 0, minus 2. So for this one, that will be 1.5. And I will use it to multiply 1 0 0 1, which is the identity matrix. So guys, if you like, you can write it as a fraction, but I will leave it like this because of my time. So 1.5 is same thing as 3 over 2. And this is scalar product. So just go ahead and get your answer. So this is the transformation matrix enlargement when scale factor is 1.5. Then for C, when we have 0.25, I'll just write the answer, guys, because of our time. So that will be 0.25 0. Then what am I writing, guys? So that will be 0.25, then 0, then 0, 0.25. And finally, when the scale factor is 3, let me put that one there. When scale factor is 3, just use 3 to multiply this. So that will be 3003. 3003. So guys, hope that is clear. Enlargement seems quite easier. Okay, just use scale factor to multiply out. So that's the transformation matrix, guys. Okay, what about this one here now? A stretched scale factor 4 parallel to x-axis with y invariant. Guys, don't forget, I need to quickly call your attention to something here now. Print screen. So when we say y invariant, the implication is that the mirror line is y-axis. Y invariant means the mirror line is y-axis. I'm going to apply this, so let me just go ahead, because of our time, let me just go ahead and complete this task now. So mean that y will remain unchanged. Okay, so now so stress is just like enlargement, but unlike in enlargement whereby you use scale factor to multiply through and the y will remain invariant. So meaning that we have to separate it now. So don't forget our base vector for x and base vector for y. Now for y invariant, so y will remain 0 1. But since it is parallel to x, then you multiply out. So 4, the scale factor is 4 to multiply the base vector of x, which is 1 0. So that's why I separate it now. So finally my answer here will now be what? So I have my x here, I have my y here. So x will be 4 0. And since y is invariant, you don't need to use 4 to multiply the base vector of y. So you just have 0 1. So that's the answer. So I'm going to apply all these transformation matrix to a real question. So that you can get your object from the image. So this is the solution 4 0 0 1. So guys, this video you can pause, you can rewind and take a look at it very well. So next. This one now, x is invariant, meaning that x should remain the same and it's parallel to y, so you multiply through that. The same thing with that last question there. So I have my y is, so x invariant. X invariant means that the base vector of x should remain the same. So 1 0 should remain the same. So and mean that the mirror line is also the x-axis. So 1 0 will remain the same, but 0 1 I will multiply out with 2. So 0 1, this is y. Don't forget that this is x base vector and this is y. And in this case, it is x that is invariant, so that's why I don't need to use scale factor to multiply that. So my final solution will now be what? My x first before y. 0 1 0, then y will now be 0 2. So the transformation matrix for stress scale factor 2 is 1 0 0 2. Then reflection now, x-axis. So now when you have reflection x-axis, what does that mean now? Let me quickly take print screen. So don't forget that the transformation matrix is very useful. That's what we are using. So 1 0 0 1. What am I saying? I mean 1 0 0 1 0. Why am I playful? Okay, 1 0 0 1. Okay, so this is identity matrix, don't forget. So you can split your identity matrix into the corresponding base vector. Okay, 1 0 0 1. Okay, now so reflection. Now if the reflection is x-axis, so meaning that it's going to flip over x, and what will flip over x? The y. Okay, so that's the implication. So now because x-axis means that x invariant, so the y, you just mirror y, then x remain the same. Don't forget to mirror y, then x remain the same. You just mirror y, then your x remain the same. That is the implication of that. So that's how to go about that. So y-axis means that y is invariant, then you mirror x. X-axis means that x is invariant, then you mirror y. So let's start with y-axis now. This question says x-axis, so meaning that x will remain the same. Okay, then I will mirror y. Okay, so our transformation matrix, then so x is invariant there, so I will repeat that, and this is solution. So I have 1 0 because it's x-axis, then you mirror y. Let me just quickly give you what is going on here. So this y here will flip over x. Mirror means that directly opposite. So originally it was here before, then it comes there. So if this is originally this is 0 1, so 0 1 will change to what? 0 minus 1. So mirror means that just add negative to it, so this will be 0 minus 1. So that's it. So x-axis means that x is invariant, then mirror y. That's reflection, guys. Hope that is clear. So how about this one? Y-axis means that y invariant, then mean that I'm going to mirror x. So from the transformation, from the identity matrix, 1 0 0 1, my base vector, this is my x, this is my y. Then so the transformation matrix here, since y is invariant, so 0 1 should remain the same. Then I mirror x, meaning that directly opposite 0. So that's it. So that's transformation matrix for that. Okay, so let's go to the next one. So this one says y equals to x, and I have y equals to minus x. Let me just bring this one up here so that I will be able to complete it there. Sorry about that. Reflection. Okay, so I can take this one down. I don't need this one here. Okay, so now let me just complete this now. So y equals to x. Y equals to x means that you flip x and y, you swap. Okay, so originally we have what? 1 0, that's x, then 0 1, that is y, and that is identity matrix. So now I mean that x will change to y and y change to x, so swap. So x, this is x, so x will change to y, so 1 0, and this is y, so y will change to x, 0 1. That's that. So just flip. So this is what we are talking about. So you just have a line here, then you can mirror across. Don't worry, I'm going to apply everything. Okay, so let's go to the next one, last one. Okay, this last one says y equals to minus x. Let me just use this one to complete that because of space there, because of the question I need to solve. So now what about reflection? Y equals to x, y equals to minus x rather. Guys, this is vice versa. You can do y equals to, is still going to work for something like this, x equals to minus y. So that let me just quickly do teach you the two together. Okay, so in case it's something like that. So let me start with y equals to minus x. Okay, so y equals to minus x now. So I have my base vector already, 1 0, sorry about that, 0 minus 1. I say 0 I'm sorry guys. Identity matrix 1 0 0 1. So now what is my solution here? The solution is the same for these two now. Whether x equals to minus y or y equals to minus x, because if you use x of your formula here, you're going to get x equals to minus y. If you use y of your formula here, you're going to get x equals to y. So the same answer here. Now, since this is, you swap here already. Okay, y equals to minus x, and originally it's supposed to be x equals to y, whatever. So what my implication means that you should swap first. So swap first now, meaning that I should write except for me to have 1 0 here, so I will have 0 1 here. Then finally, except for me to have 0 1 here, then I'll have 1 0 here. Now since it is negative, then both carry negative. So that solution work for both. Guys, hope that is clear. So at this point now, let's get through the application. So hope you can derive transformation matrix for any any transformation question. Okay, so this question here says A reflects y equals to minus x using why do you start with this? Why can't you give me simple one, guys? Okay, that's not a bad deal. Okay, I don't know. Okay, so using transformation to do this, that's very interesting. I need to quickly let me just hide this one here because that's second question. So let me take print screen now. Okay, guys, how do you use transformation to complete? Because I want to use transformation matrix. That's the question. I'm asked to use transformation matrix, so I cannot use any other. Okay, I want to produce an image of this object. So let's tag this one. This is the object. I want to produce image based on this transformation. Okay. Now the first thing now, since it's center 0 0, let's work with center 0 0. So let's say okay. So mean like the origin is okay. Sorry, I don't even need center 0 0 here. Whatever, it's not rotation. Okay, sorry about that. So this is reflection, very easy. Okay, so guys, let's quickly do something first. I need the coordinate for A. The coordinate for A is 1. Hey, don't forget x before y. 1, 3. So my A is 1, 3. You write it as a base vector. It's meant to be something like this: 1, 3. Not 1 comma because it's a vector, so we don't put comma in vector. So, but I'm not going to write it as this. I'm going to write it as a column vector, not as a row vector. So my A now, let me just write my A is 1, 3. Okay. Then my B is 3, 3. Guys, hope you know how to determine your coordinate. That's very easy, guys. That's primary. That is KS1 and 2, guys. Okay, so this one is the coordinate for C is you just write the coordinate as a base vector, guys. So 3, 2. So 3, 2. So I have this now. So I will see what will happen to it now. Okay, now so the next thing is what is transformation matrix for y equals to minus x? The same thing, you can apply this. If that the y equals to x mirror line, just go ahead and do what I'm going to do now. So this will be the most demanding. That's why I choose this type of question. So now the transformation matrix first. Where can I derive that? Let's put it here now. Originally I have 1, 0, that is x, and my y is 0, 1. Okay, now then since I want this one now, I'm going to swap first. So this is y, 0, 1, and this is my x, 1, 0. Swap first, then add negative to both. So this is transformation matrix for this. Okay, now what we now do now is to use the transformation matrix to multiply this. And in the moment I get to know what happened here, then I will not need to multiply through for the remaining one. I will just apply it like that. So I will just apply this one with for this. So let me just multiply now. So use transformation matrix to multiply. So the transformation matrix for a reflection y equals to minus x is what? 0, minus 1, then minus 1, 0. Then use the transformation matrix to multiply the components, each component. So let me use this for 3, 1. For any of this, let me go for 1, 3. So because of my time, I will not need not to do. I will just look at what happened. Then I will apply automatically to the remaining base vector, or better still coordinates. So don't forget how to multiply. You multiply in transformation. How do you multiply? It's row by column. Row by column. Let me change this one. Row by column. Don't forget. That's the row. So row by column. So now what do we have here? 0 times 1 plus minus 1 times 3. So let me just write my solution here now. So I have 0 times 1 plus minus 1 times 3. That is minus 3. Then for this one now, minus 1 times 1 plus 0 times 3. That is minus 1. So what do you observe? Originally I have 1, 3. And it changed to what? 3 minus 3 minus 1. Mean that you swap first. So I don't need to waste my time again. So my C prime is what? Minus 3 minus 1. Then my A prime, that's the image coordinate. My A prime means that I should swap. So 3, then 1. Because it originally is 1, 3. So I'll change to 3, 1. Then you put negative, negative. Because that's what happened in case of C. Then finally for B prime, B prime is 3 3, so it's still, whether you swap or not, it's still 3 3. So 3 3, then you negative negative. Okay, so that's all. So now let me start with A. Minus 1. A is minus 3 minus 1. So minus 3 x-axis, minus 1 y-axis. So this is my A prime here. I don't know that asterisk whether it makes sense for you guys. So let me just write the A prime there. So that so A prime is minus 3 minus 1. And this is it here. Minus 3 minus 1, this point here. Then my B prime is minus 3 minus 3. So this is minus 3 minus 3. So this is my B prime here. And my C prime is minus 3 minus 1. Minus 3x minus 1y. Minus 3x minus 1y. Oh, why am I like this? Oh my God. So this is C actually. My A is minus 3 minus 1. Minus 3 minus. What am I doing? Oh, I'm sorry about that. So C is 3 2 originally. Okay, I did A here. So C is 3 2. So that would be minus 2 minus 3. What am I going to do now? Let me just clean everything, guys, so that I don't confuse you guys. I'm sorry about that. Okay, so originally this is the one I derive here is for 1 3. That is A. So this is A prime, not C prime. So can I just clean everything? Okay, so now let's get started now. The one I derive here is 1 3, and 1 3 is A. So my A prime is minus 3 minus 1. My B prime will be minus 3 minus 3. Then my C prime. So if you look at what happened to A, you swap first. 3 up, then 1 comes down, then you add negative negative. So that one is going to happen here. So 2 goes up, then 3 down here, then you add negative negative. So that's all. So my A prime now minus 3 minus 1 here. So let me just write it. A prime. My B prime minus 3 minus 3. Because whether you swap or not, minus 3 minus 3, they add negative. So this is minus 3 minus 3 here. So this is my B prime. And my C prime minus 2, then minus 3. So this is my C prime. Then you can join now with a straight line. So join C prime to B prime, B prime to A prime, then A prime to that. Okay guys, hope that is clear. So that is reflection y equals to minus x. Guys, I would have loved to apply for everything, and if you don't mind, okay, so that you understand better, let me just answer one question here. Let me answer one question, because this mirror line, this is very easy. This mirror line now, okay, let me just draw the mirror line so that you understand what happened there. This is the mirror line. This is y equals to minus x. If that will be y equals to x, it will be like that. So y equals to minus x. If you want to do the conventional way of completing this task, A will move 1 2 3 4. Then you do 4 down to 1 2 3 4. This is correct, and you complete like that. Okay, but let me just do for one more so that you understand better. Okay, what about if the mirror line was to be y-axis, that is y invariant? So what will happen? So if the mirror line is y-axis, then that means y invariant. Y invariant means that y will remain the same. So 0 1 will remain the same. Then you mirror x, that is minus 1 0. So if you use this one to multiply through, let me just use it to multiply A now. If I want to use it to multiply A is 1 3. So let me see what will happen. Then from there I will be able to finish up. So don't forget how to multiply. Minus 1 times 1, then 0 times 3, that is minus 1. Sorry about that. So this is minus 1 here, minus 1. Then this one, 0 times, then this is 3. So what happened? 3 remain the same. That is why it remain the same. It's just x that put negative. So meaning that this is my A prime now. My solution now for this one, let me change the color now so that you know the one I'm working with now. Let me change to this color now. So for question, if the question were to be mirror line is y-axis. Y-axis mirror line. So y-axis mirror line will give me the following value. My a, I have my a already. Then my b will be minus 3, because y remain the same. Then my c will be minus 3, 2, because y remain the same. The first value is x, the second value is y. So now minus 1, 3, minus 1, 3 here. Then minus 3, 3, minus 3, 3 here. No, minus 3, 3 is here. Minus 3, 3 here. Then minus 3, 2, from 3, 2, minus 3, 2. So minus 3, 2 here. So join now and see what happened there. So because this one, you're going to understand it better, because you know that, oh, if I want to do mirror, just count how many steps to do. So one step towards the mirror line, then you count one step away to get your a prime originally, if you don't want to use transformation matrix. Then from b to the mirror line, 1, 2, 3, then you count 3 steps away, 1, 2, 3. So this is b prime. Then from c to the mirror line, 1, 2, 3, then you count 3 steps away, 1, 2, 3. This is c prime. Do you see that it works? So that's it, guys. So that's how to apply a transformation matrix. So the moment you can derive your transformation matrix, you just use it to multiply its coordinates, then you get your image. So let me just tag this one I2. I2 means that when the mirror line is y-axis, and this is I1, image 1, that's when mirror line is y equals to minus x. Guys, good application. So next question. So I'm using transformation matrix to complete this one now, but I need not to, because of my time, to use the conventional method. So I want to use transformation matrix for this now. Rotation 90 degree anti-clockwise. Wow, this is not funny, guys. Okay, so since center of rotation is 0, 0, this is 0, 0, and it's not labeled, so but it is 0, 0, guys. So the first thing is to just determine my respective coordinates. Let me label this one A, let me label this one B, and let me label this one C. So what is my A? Guys, don't forget to move x before y, and I'm going to write it as base vector. This will be my A, because I want to use transformation matrix to multiply out. Okay, and this is C. So my A now, from the center of rotation, guys, you have to write x before y. So this is 1, 1. So this is 1, 1. From the center of rotation to B, 1, 2, 3, 4, 1, 2, 3. That is 4, 3. 4, 3 because to the right hand side and up. Then from center of rotation to C, 1, 2, 3, 4, 5, 1. 5, 1. 5 to the right hand side and 1 up. Okay. So that's that. Then let me now go ahead with transformation matrix for 90 degree clockwise. So 90 degree clockwise, let me derive that. Guys, I don't need to waste much time here. I will just, because you understand the concept already. So this is my 0, 1, and this is my 1, 0. This is minus 1, 0, and this is 0, minus 1. So let me write the transformation matrix here. Okay, so 90 degree clockwise from x, this x, and this is y. From x, 90 degree clockwise, so 1, 0, change to what? 0, minus 1. So 0, minus 1. Then from y now, 0, 1, change to what? 1, 0. So this is the transformation matrix now. Okay, so I'll just use transformation matrix to multiply out, then I see what will happen. I'm not going to apply to A because A is 1, 1. So let me apply to B so that I'll just use the same step. So let me use this one to multiply B now. So B is 4, 3. So what will that give me? So don't forget to column by row. So 0 times 4 plus 1 times 3. That is 3. Minus 1 times 4 plus 0 times 3. That is minus 4. So what happened here? You swap the coordinates, then you add negative to the last coordinate. So this one definitely will give me 1 minus 1. That's A. Then I have my B already, but let me write it again. So my B, swap first, 3, 4. Then add negative to the 4, to the down one, to the Y value. So this one, swap first, 1, 5. Then add negative to the Y coordinate, minus. Okay, so that's that. Am I correct? Okay, guys, I don't know why I'm doing rotation. Yeah, it's rotation. Oh, this enlargement question. Oh my god. Oh, this is enlargement question, and this rotation is up there. Why wasted time? But it's a good one. You guys you learned that already, but I'm sorry about that. Rotation question is up. This rotation. Oh my god. Why did I do this? Ah. Well, I was surprised that how come I don't have negative there? Oh, wasted. Well, it's not a wasted time. Okay, guys, I know what happened already. Oh my god, this is not funny. Okay, so I'm sorry about that, guys. So this rotation question, that question is for enlargement anyway. So my A is 1 3. My A is 1 3. That will enhance your knowledge anyway. That's not a, it could be a mistake, but it's also an advantage for you guys. So 1 3. So B is 3 3. B is 3 3. And my C is 3 1. Guys, X before Y. You know how to find your coordinates anyway. So 90 degree clockwise. I don't know if I should derive it again. I can't. I don't normally. I can't cram that stuff. So let me just do it again. I think that will help you guys better. So this here is 0 1, and here is 1 0, and here is 0 minus 1, and here I have minus 1 0. So the transformation matrix now we use it to multiply. Let me just write it here. So once what 90 degree clockwise, okay. So 1 0 change to 0 minus 1. 0 handwriting. So 0 minus 1. So 1 0 change to 0 minus 1. Then 0 1 change to what? 1 0. So then use this one to multiply. Let me use it to multiply A. Okay, let me use it to multiply A. So don't forget row by column. Okay, so 0 times 1 0 plus 3. So that is 0 plus 3, that is 3. Minus 1 plus 3, that is minus 1. So for A, you have swap first, 3 1, then add negative. For B, swap 3 3, then negative. So that's 3 minus 3. For C, swap first 1 3, then add negative to the y value, minus 3. So now for A now, I have 3 minus 1, 3 minus 1. So here, this will be my A prime. My B, 3 minus 3, 3 minus 3. So this is my B prime. And my C, 1 minus 3. This 1 here, minus 3. This is my C prime. Then you can take your line and join now. Guys, you can see how beautiful this is, guys. Transformation matrix can be a very good advantage. I need to do that very well. So, and if you observant, if you look at this one now, 90 degree, 90 degree, what am I doing? 90 degree clockwise. Yeah, but this is longer somehow. 2 2 is meant to be 1, so I did something wrong. Okay, let me take a look at that again. So my what do I have here? 1 3, 1 3, 3 2. C is don't mind me. Okay, I'm sorry about that. I don't know why I'm just doing this. Okay, so the coordinates, my coordinates wrong for what? 3 2. That is for C. My C coordinate is wrong. Okay, I can't be wasting my time like this, my god. No, I'm not going to waste much time. Let me just continue like that. I will just change it. So A is 1 3 because I'm just in hurry. Then B is 3 3. Then C is 3 2. 3 2, not 3 1, 3 2. Don't mind me, I'm sorry about that. And I should have cleaned everything, guys. It's okay anyway. So 3 2. So I know what happened there. So let me just do this again. This is 0 3, and this is minus 1 0. So minus 1. Okay, now swap. So I have swap 3 1, then add negative, then swap 3 minus 3. Finally, for some reason I just, this video seems to be quite long. Okay, so swap first 2 3 and then add negative here. Okay, so now I'm not going to add ABC again. Let me just be fast. So 3, this is 3 minus 1 here. This is my A, but let me do that so that in order to confirm. So this is my A prime, my A prime. Okay, then B, 3 minus 3 here. So this is my B prime. Then my C, 2 minus 3. Better, thank God. So this is my C prime. So I can join now. Okay guys, if you look at this now, if you observe that when you do 90 degree, this comes down here, so B comes then A. So that's it, correct. So guys, this video you can pause, and I wouldn't know, I didn't really purposely make mistake, but that mistake also help you to enhance, it will help you to understand better. Okay, is that the last question? Wow. Okay, this one here now, 90 degree. Okay, thank God this is scale factor, this is enlargement, so that will be quite, I should be faster. Yeah. So guys, since scale factor is 2, implication is that I'm going to multiply out by 2. Okay, just multiply out by 2. So what's the coordinate here now? So the identity matrix is 1 0 0 1. So the transformation matrix for this will now be what? 2 0 0 2. So I'll use 2 0 0 2 to multiply each coordinate now. So now I need to label. I don't need to label. Let me just, this one here is from here. I did this before, guys, don't forget. From here 1 1. So I'll use it to multiply 1 1. Let me just label it, guys. I don't want to. That's 1 1. Then B is 1 2 3 4 1 2 3. So that's 4 3. B is 4 3. And finally C from here 1 2 3 4 5 1. So this is C here, and that is 5 1. I need to confirm that again so that I don't make that kind of mistake. So my A is 1 1, my B is 1 2 3 4 1 2 3, and C is 5 1. Correct. So let me use it for C, then we know what happened there. So let me use this to multiply 2 0 0 2 to multiply what? 5 1 5 1. So don't forget row to column. So 2 times 5, that is 10, because this is 2 times 5 plus 0. Then 0 times 5 plus 2, that is 2. So what do you observe now? Just multiply each coordinate by 2. That's it. That's all. So definitely, so this will be 2 2. This one here will be, let me just use another color that this time around, so that the image now, let me use that in red. So the image here will be 2 2. The image here will be 8 6. And the image here will be 10 2, just as we have it. But you count from here, that's it now. So 2 2 1 2 1 2. So I have the first one here. Then from here again, 8 6 1 2 3 4 5 6 7 8, then 6 1 2 3 4 5 6. Yeah. Then finally 10 10 what? 10 2. I said where I put it right. Let me write it too very well. 10 2. Sorry about that. 10 2. So this is 8 here. So this is 9 10. Then 2 1 2. Let me confirm that. 1 2 3 4 5 6 7 8 9 10 1 2. So that's all. So just join, guys, and that's all. And you need to confirm is that true? Just take a corresponding stuff. Let me go with this A to C, and this is A. So this length here 1 2 3 4 4 square boxes. Then I should have 8 square boxes here. 1 2 3 4 5 6 7 8. So similarly this and that. So that is correct, please. Next question. Oh, this, yeah, thank God, this is the final question. Reflection. Okay, so reflection x-axis. Okay, let me quickly go ahead and get my stuff there. So reflection axis, I'm going to use transformation matrix to complete this. And reflection x-axis means that x is invariant. So 1 0. Then my y, y we you mirror y. So y is meant to be 0 1, and since you mirror it, so that will be -1. So this transformation matrix reflection x-axis, that is x invariant. X invariant means that x remains the same, then you mirror y. Guys, you can rewind the video and get to understand that better. Okay, so this is transformation matrix. I'm going to multiply each coordinate now. So let me tag this place A. This is A, this is B, and this is C here. So let me see what will happen to A, then I can. So my A is x first, -2, -4, -2 and -4. My B is -4, -4. Okay, and finally my C is what? My C is -4, -1, -4, -1. Okay, so let me just use it to multiply -4, -1, then I'll see what happens. Or better still, this one here. Let me use it for -4, -1 anyway. Okay, I need to write it here. Can I just write -4, -1 here, guys? -4 and -1. So don't forget row by column. So 1 times -4, then 0. So this is -4. Then 0 times this 0, then this is +1. So now -4, meaning that mirror line, do you see now x remain the same, but y you mirror it. So x remain the same, that's why it is x invariant. So my image now, let me just put image here. Let me put object here. So my image now, so do you see what happened now? -4 -1 change to -4 1. So x remain the same, then add negative sign to the y coordinates. X remain the same, then multiply the y value by negative. Okay, then x remain the same, then multiply the y coordinate by negative value. So that's all. So I have -2 4, -2 4 here. Then I have -4 4, -4 4 here. Then finally I have -4 1, -4 1 here. So you can join now. Guys, I'm correct. So can I just tag it? This is C prime. This is B prime. And this is my A prime. Why am I like this? This is my A prime. So if you want to confirm, guys, don't forget since the mirror line is x-axis, so from C to the mirror line 1 step, then 1 step away. From B to the mirror line 1 2 3 4, 4 step away to 1 2 3 4. From A to the mirror line 1 2 3 4, 4 step away to 1 2 3 4, guys. And this is the end of our tutorial, guys. At this point, I want to say, guys, don't forget to subscribe to my channel. Hope you enjoyed today's section. Quickly, I need to show you something. Let me just quickly. Okay, guys, don't forget to subscribe to my channel, and there are more. I made some video on transformation before now, and if you look at this is transformation part 2 and transformation part 1. So here you can learn better on translation, reflection, enlargement, and rotation. Part 2 dedicated to rotation only, and also you can get access to board work here. So just type this address on your URL, test.com teaching resources shop Alukoshayo. Then you have a lot of board work on transformation and other resources that will be very useful to you. Okay, guys, at this point I want to say do have a great day ahead and take good care of yourself. Bye bye, guys, and don't forget to subscribe to my channel, or better still click like, guys. Bye, guys. Do have a great day ahead. Subscribe to my channel, guys. Bye. Love you.